look like as soon as the ligand initially moves, whether it's the insertion or the migration. And it'll convert very quickly between square pyramidal and then trigonal bipyramidal. And that's how you can get the trans form.
Square pyramidal to what?
So initially it'll be square pyramidal, and then it can go into trigonal bipyramidal very easily because both of those have five coordinates or five
That's
coordinates.
what
And the
causes it
trigonal
to do the transfer cis.
Yeah, and that's allows them to get the ligands into different arrangements when it
So that
converts
more
back.
polar solvent would come in and bind, or come in and block that site.
So yeah, that's kind of what I think they maybe hint at in the paper, that I don't really make it obvious, is that a polar solvent can at least serve as a ligand. And so it can try to stabilize the metal compound, whereas the CS2, which is completely nonpolar, is going to want nothing to do with the metal, and so it doesn't stabilize it at all. And so apparently if you can stabilize that transition, that'll give you a little bit better
So
formation of
is,
trans.
in the CS2, is it still going cis and trans, but it's switching back so fast that it's not being recognized, or is it?
The equilibrium would still be there.
Would you-
Well, so that's for, I don't know that the NMR percentages, if you go back to the prior one, I don't know that that's after, no, it does say at equilibrium. Huh, that's strange.
See, because it looks like it would still be switching no matter what. It has the ability, if the
Yeah, it should
acetyl
be.
group would stabilize it, then it would still,
So it must stabilize a transition between those two forms. But they don't really go into that in the paper. They do a little bit more. You didn't report on any of the carbon-13 studies they did though, did you, Adolfo?
I read more about the flash chromatography thing because I thought it was weird.
That is weird. Does everybody understand why that's weird? Can you explain to people why that's weird?
Because it's supposed to be the cis one that goes after the trans one, because it's supposed to be bulkier, right? Like kind of slower kind of thing, going through the column there. Then like it shouldn't just go through faster. Because some
Go back. Which one came out first?
cis came out first.
cis came out first instead of the trans.
Now that seems like it should be correct, right? I don't know. Why is that weird? Because it was on silica,
Yeah,
so we expect.
they expect the trans to come out first instead of the cis.
When your cis want to come out first.
Oh wait, sorry, I'm thinking of.
Yeah, wouldn't it be polarity?
I'm
If,
thinking
if
of
it's not.
something else. Yes, that is why it's strange, because the cis should be more polar than the trans, but it still comes out first. That's the weirdness. If they don't say anything about it, they're just like, yeah, it's strange.
No, it says here they have another example of manganese bromide tetracarbonyl, which does the same. Like it has shown the same kind of behaviors. That's why when I read the paper of the people, Stones and Jones, Jolie and Stone, and they mentioned that throughout the experiment they kept like missing the cis part, and it didn't make sense to them why would this happen when you're like supposed to have it later. Kind of what we did with the column that we kept pushing and pushing and pushing through, and we were like keep looking and looking and we didn't find anything.
Right.
That's kind of what happened to them, and then they just said, well, let's analyze that first part. Like even though like they had to do it several times, until they said, okay, I guess the only way is that it's in the first part of the fraction and not what we're getting. So they came back and they found that this complex cis manganese bromide tetracarbonyl will have the same cis trans kind of thing going on.
As far as the cis coming out first.
Yeah.
It's weird.
The steric bulk, like.
I don't know. For your reactions there, you obviously have a typo. What's the typo?
Number of carbonyls.
No, no more carbonyls is fine. What's wrong with your triphenylphosphate?
Yeah.
You got 8 benzene rings coming on instead of 3.
I think it was 3.
Yeah. Go to, sorry, I guess we're running out of time. Go to the next slide for me, really quick. One more slide. I want to ask a question. So the arrow that you have pointing to that specific peak up in A, now the top one's supposed to be cis and the bottom one is trans, right?
Yeah.
So were they following that specific peak as it gets smaller because that was the way to follow the cis as it disappeared?
Yeah, they're supposed to be, like, if you look at that peak, that's what we showed you with the other peaks increasing the size. That is moving from cis to trans as they hit more the solution.
Okay, so that one is growing or it's getting?
No, that peak that they selected is going back.
That's getting smaller.
Yes,
Okay.
and you can see that the resolution is getting like weird here because these two are defined peaks. But
Right, and then it's becoming more of a shoulder. And
yeah, when they crank up the heat, you can see that one's coming back with all these parts coming down.
Yeah.
As you can see, like this is pretty much the previous one almost. And you can see that the trans go all the way down as well here, and then that one just disappears pretty much, or gets like joined with this one.
Gotcha. Okie dokie. Thanks, sir.
Hey, in my defense, the N looks like an 8 in that paper.
At least you kept your train of thought more than I did.
My what?
Your train of thought more than I did.
I don't think so. I think it was a train wreck.
I'm looking at this now, I'm like, okay, that probably would have been to the
I
back.
thought it was an 8.
Yeah.
I guess if I thought about it,
Some
I
of
took
those
it
papers
3.
though, like,
That
I had to squint at some of those things, I'm like, is that a methyl group or is that?
Yeah, the old papers. Well, and the original copies I have aren't great, so.
It's kind of hard too because you're trying to think of all these things and then
Yeah.
they're not very detailed.
There's some things up there I didn't talk about, like I just had listed and I'm like, just gonna keep going.
I just like,
Yeah, I would say papers overall have gotten better since the 60s and 70s.
yeah, because I read these papers and I thought when you said, oh, you have to do a presentation of a paper, I thought, God damn, it's gonna be like a 20 pages long shit,
No,
like
these are
how it is
short.
now.
My problem is I just forget, like, I get up there and I'm like, I have things to talk about and I just forget, I'm just like, nope, my brain's just blanking on me. I'm just gonna keep trucking through.
My issue is that I run through stuff and then I don't meet the time.
I do, I get nervous. For whatever reason, like, I can get up and talk in front of people, but if you tell me I have to give a presentation, it's gone.
So we have to do